Hello, in this session we're going to discuss pairwise comparison. The main goal of the comparability tests is to compare two sets of trend data whose mean functions are represented by joint point regression. Examples of this could be the comparison of segmented line regression models among different age groups and the comparison of incidence or mortality rates between two different regions. In pairwise comparison in joint-point trend analysis software, specific interests are to test if two joint-point regression functions are identical, which is called test of coincidence, or if the two regression mean functions are parallel, which is called test of parallelism. In short, these tests are to test if the two joint-point mean functions are parallel or identical. The null hypotheses of the coincidence and parallelism tests are presented in this slide. The test statistic is presented in this slide where RSS denote the residual sums of squares for the set 1 and set 2, and D1k and D2k are the degrees of freedom for these sets. The p-value of this test is estimated using the permutation distribution of the test statistic. In joint-point trend analysis software, this is done by using a Monte Carlo sample of the n factorial datasets using a random number generator. The minimum and maximum allowed number of permutations for this test are 1000 and 10,000. It is, however, recommended to have at least 4,499 permutations, which is the default in the software, for greater consistency in the obtained p-values. It is important to note that autocorrelated error models are not available with these tests, and these methods cannot be directly applied to tests for the same locations of joint points. For using these tests, the software requires to use the parametric method for the calculation of the confidence intervals. In order to access pairwise comparison tests after loading the data in the software, we will come to Advanced Analysis Tools tab, activate pairwise comparison, and choose the test that we intend to use between parallel and coincidence. We can change the significance level of the test here, and we can change the maximum number of randomly permuted datasets. Here, as mentioned in the theoretical part of the video, the default value is 4,499, which can be increased up to 10,000 times. However, this would increase the computation time needed for the joint-point trend analysis software to analyze the data. Here, if I push this button at the moment, since the confidence interval method of calculation is set on empirical quantile, we'll see this error that empirical quantile method can't be used. By clicking on this option, we will automatically use the parametric method. However, we can also come to the method and parameters tab and choose the parametric method here. So here I'm going to push this. The error is seen, as you can see. I'll push the parametric method to use parametric method. Here, as you can see, the best model is for male and female with male is not coincident, and for male and female with female, again not coincident, and for male and female, again the best model is the non-coincident one. And in the pairwise comparison tab, we can see the p-value of this test and its significance level as it can be seen here with a K max of 1 joint point.